in this portion we are going to deal with the topics like the convection and the radiation. Now these two are the other methods of the conduction of heat and their transfers. In this method we will see what are its differences in the three modes of the transfer of heat, and then we are going to deal with the law called the Kirchhoff's law. Let's start the topic convection, radiation and the laws associated with it. Now here we will first deal with the topic convection, then with the radiation, and then we'll have Kirchhoff's law. Let's see what exactly is this process of convection. In convection, the heat is transferred from one place to the other by the actual motion of the heated material. This is important. In the case of convection, there is actual motion of the heated material. If you remember, in the conduction and convection, both of the processes, you need material medium for conduction to happen. But in the conduction, the atoms that are oscillating, they don't move from their position permanently. They are simply oscillating about their mean position. In convection, there is actual motion of the heated material. So this is the difference between conduction and convection, although both involves the material medium. Examples are given like in a hot air blower, air is heated by a heating element and is blown by a fan. The air, it carries the heat wherever it goes. The heated air that are vibrating fast, they will carry the heat and they will transfer it. If the heated material is forced to move, say by a blower or a pump, the process of heat transfer is called forced convection. Now when you force the motion of the material medium, it is called forced convection. Like in the heating, like if you simply have a stove kept here, there is fire here. Then the air that is in contact, it will simply get heated up and go up. Cold air comes down, it again gets heated up and goes up. So it's happening naturally, it's happening on its own. But if you apply a fan, here, that blows away the air, which will carry the heat. This is a forced convection. Okay. Now what is radiation? The radiation, as we have talked, that it does not need a material medium for heat transfer. That was the first thing that we differentiated conduction and convection from radiation. Okay, it does not need any material medium. This is the characteristic feature of radiation mode of heat transfer. Now energy is emitted by a body, and this energy, it travels in the space just like light. Just like light. What is light? It is also a radiation. It is also an electromagnetic wave. So the electromagnetic waves or the radiation. Now these electromagnetic waves and radiation, they travel without medium. It does not need a material medium to travel, like the light that is coming from the sun. Now if you see, here is the earth and then you have the sun. Now between earth and sun, you have the earth's atmosphere here. In the atmosphere there are molecules, but in here there is a vacuum. This is the sun. There is a vacuum. How is it that this heat, you feel the heat at this place, right? You feel the heat on the earth sitting, you feel the heat of the sunlight. Now how is that happening? How is the heat is being transferred? It is to the radiation, which does not need any vacuum, which does not need any material medium. It can travel in the vacuum. Okay. When it falls on a material body, a part is absorbed and thermal energy of the receiving body is increased. Now what happens when something receives the radiation? Now this is a body. There is a radiation that is coming in. When it reaches here, what will happen? Some amount may be absorbed and some amount may be radiated. Okay, this energy is coming, it is absorbed and some amount may be radiated. The absorbed one, what it will do? It will raise the temperature of the body. Okay. Thus the energy emitted by body in this way is called radiant energy. Now this energy that is being reflected from here, it is called radiant energy. Radiant energy. Why it is called radiant energy? Because it is being radiated from the body. Radiate means coming out from the body. it absorbed some radiation and now it is emitting an entirely different radiation. See, be very clear, this radiation that is being emitted is not the same as the one which was absorbed. The one which was absorbed has a different wavelength, different frequency. It was absorbed, and then the body, by virtue of its temperature, it radiates a different frequency. This should be clear. It's not the part of the radiation that is being radiated. It's due to the temperature of the body that is being radiated. Okay. It also refers to energy itself which is being transmitted in space. The word radiation is used in two meanings. It refers to the process by which the energy is emitted by a body. So radiation is the process by which a body emits radiation, emits the radiating waves. It also refers to the energy itself which is being transmitted in space, and the transmitted the energy that is coming from the sun or from distant stars, they are also called radiation. Now, blackbody radiation. What exactly is this blackbody? Now, consider two bodies of equal surface areas suspended in a room. One of the bodies has polished surface and the other is painted black. You have two bodies kept in a room. One is painted black and this is polished. After sufficient time, the temperature of both the bodies will be equal to the room temperature. So now suppose this is kept in a room. Room has some temperature, suppose T. What will happen if you keep these two bodies in the room for a long time? These two bodies attain the same temperature T. Okay. Now, as the surface areas of the bodies are the same, equal amount of radiation falls on the two surfaces. Now, if you consider that they are of the same radius r, what will happen? Both will receive the same amount of radiation. See, the room is at some temperature, so the room is radiating energy. This is being absorbed by this body as well as this body, right? Now, the polished surface reflects a large part of it and absorbs a little. Now, since this is polished, what will happen when the radiation falls on it? It reflects most part of it and absorbs only very small part of it. Now, this is a black surface, this will absorb most part of it and then it will radiate. While the black painted surface, it will reflect a little and absorbs a large part of it. So, this is what is happening. This is due to the virtue of its surface. So, now under this background, we will define what is a blackbody radiation. So, now as the temperature of each body remains constant, now as the temperature is constant, we have told that both attain the temperature of the room. So, now both have the same temperature. We conclude that the polished surface, it radiates at a slower rate and the black painted surface radiates at a faster rate. How? We talked here that since this is a black body, it will absorb more. Now, since it is absorbing more, but it is at the same temperature T all the time. What does it mean? That means it must be radiating also, and it will be radiating as much as it is absorbing after attaining the temperature, room temperature I am talking. After it is at the constant temperature T, now there is no change in temperature. What that means? That means that whatever energy it is absorbing, it is also radiating the same energy. Okay. That means the black body will also radiate more energy because it is absorbing more energy, and the polished surface which is absorbing less energy will also radiate less energy. What is the inference from it? That the good absorbers are also good emitters. I hope this is clear. Now, a body that absorbs all the radiation falling on it is called a black body. This is the definition of the black body. When you absorb, it will absorb all radiation, whatever is falling on it is called a black body. Now, this is a theoretical concept. It's very difficult to make a black body. It's very difficult to have a black body in practicality, but there is a way of making a black body. We'll talk about it. Such a body will emit radiation at the fastest rate. Now, since this is absorbing all the radiation, what will happen? It's absorbing highest amount of radiation. So, it will emit also, being an emitter, being a good emitter because it is a good absorber, it will also radiate highest. The radiation emitted by a black body is called a black body radiation. Now, this emitted radiation is called black body radiation. Now, how do we make a black body radiation? Is it possible to have a body that will absorb all the radiation? Practically not. but we can make an almost black body radiation. If you have a small hole here such that a radiation enters it, what will happen? This radiation will strike here, then it will be reflected, then coming here, it's being reflected all the time, right? What is happening is that because this wavelength that enters, it is being reflected all the time. When it is reflected, a different frequency comes out, right? So what is happening is that any frequency that goes in is being absorbed within this body, and a particular frequency comes out of this body. Now this particular frequency could be anything. That means it may radiate the frequency in any range, because it's being continuously absorbed and then it's radiated back. So this is like a black body. Okay. Now what is Kirchhoff's law? So before we define what exactly this is law, let's define certain terms. One is the emissive power. What is this emissive power? Emissive power, it depends on the energy radiated. That is energy radiated per unit area. Now this is what you have to remember. This is per unit area, energy per unit area, per unit time, per unit solid angle along normal to the area. So let's draw a sphere, and then you have this. Consider at this point. Now if you consider at this point, you will have to construct a solid angle here, omega. Now the energy that is radiated normal to this surface per unit area, per unit time, per solid angle will give you the emissive power. Okay. What is absorptive power? Absorptive power of a body is defined as the fraction of the incident radiation that is absorbed by the body. Now if there is incident radiation I, and what is reflected is R. What is absorptive power? Absorptive power will be I minus R by I. This is the absorptive power. It's the fraction of the radiation that is being absorbed. That will be the absorptive power. Now using these two terms, we have a law that's called the Kirchhoff's law. Now this Kirchhoff's law, it gives you a relation between the emissive power and the absorptive power. The ratio of this emissive power to the absorptive power, it is a dimensionless quantity. See this E by A, this is a dimensionless quantity because both are the energy absorbed per unit area, per unit time, per unit solid angle. This E by A is a constant. This E by A is a constant and is equal to some ratio. For a black body, this ratio becomes 1. For a black body, this ratio is 1. Else, it is less than 1. Now, it tells that if a body has high emissive power, it should also have high absorptive power to have the ratio same. Now, since this is a value of a body, like this is the body, it has a value suppose 0.5. Right? So, this is a constant. So, that means this should also always be a constant. So, if you increase the emissive power, if the emissive power increases, then the absorptive power must also increase to keep this ratio constant. This is again very similar to the theory that we discussed on how good absorbers are good reflectors. It is the same thing in the form of a law. Now, the ratio of the energy of radiation emitted by a black body at 27 degrees Celsius and 927 degrees Celsius is. Now, we talked about the energy. If you remember, the formula for the energy radiated is sigma into T to the power 4. This is the energy radiated per unit time, per unit area. So you have to find out the ratio at 27 and 927. Now here this temperature is in Kelvin. This you have to keep in mind, this temperature is in Kelvin. So that means this is 300 Kelvin. This is 1200 Kelvin. What is the ratio? E1 okay by E2 1200 into 4. So what we have here is sigma cancels out. Right? This is 300. This is 1200. So what you have here ratio is the correct answer is 1:256. Okay. So in this portion we have talked about the other two modes of the transfer of heat, that is the convection and the radiation, and we also talked about the Kirchhoff's law, and in defining that we saw what was exactly the emissive power and the absorptive power. In the coming part we are going to deal with the other two laws of the radiation, that are, one is the Stephen's law and another one is the Wien's displacement law. So stay tuned to Ask IITians for more on these topics.